Hello friends, I Prof.Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head Control System Engineering. So friends, as far as our today's session is concerned, so we will try to learn the application of this Routh Stability criteria which is used in this control system engineering phenomena. So in their previous session already we had learned how to use this Routh stability criteria in order to determine the overall stability of this control system. So from stability point of view, this Routh stability criteria or the Hurwitz criteria, these two criteria are being used by this control system engineering phenomena to decide the overall stability of that system. So let us quickly go through. The objective for this session is to so as you can see, such type of control system we do can have with us, or more prominently we do can say that this is the closed loop type of control system, because we are having the significance of this feedback signal in that given closed loop type of control system. So as you can see, this negative sign is being mentioned within the lower terminal of the summing point. And as far as this adjacent terminal is concerned, so to this adjacent terminal we used to have this forward path whose gain is exactly equals to how much here? Gain equals to k divided by s into s square plus s plus 1 into s plus 4, right? So this entire term which is written within this rectangular box is nothing but what? The forward path gain, and its feedback gain is nothing but what? We do can say that it is a unity gain feedback. What type of feedback we are having with us here? As we are having the negative sign, so we clearly we know that it is the closed loop control system with unity feedback, which consists of this negative type of feedback. So quickly we need to recall how this CLTF is to be determined, or we do can say that the closed loop transfer function for closed loops transfer function for this unity gain feedback system, how it will look like. So we need to recall such type of scenario where see, this is the gain of this forward path, and this is the unity gain feedback with this negative sign, and this is C, and this is nothing but what? R. So which is quite look like similar to the objective which is given in this problem. So here what we need to do, from stability point of view, here we need to decide the range for this unknown variable, call it as a k, which is denoted in this forward path. So for that purpose, as I told you earlier, whether this Hurwitz criteria or Routh stability criteria, currently we are going through this stability criteria, always it will try to deal with the characteristics equation of the transfer function, right? So characteristics equation is nothing but what? The way in which you are equating the denominator term of this transfer function. So first of all, we need to recall the closed loop transfer function for such type of unity gain feedback system. So its transfer function equals to what? It is the ratio of output to the input, C of s upon R of s. So it will be G of s divided by 1 plus G of s into H of s. And when this denominator, that is nothing but what? 1 plus G of s into H of s is being equated to 0, this whole term can be called it as a characteristics equation. This Routh stability criteria always deals with this characteristics equation. So first of all, what we need to do, we are supposed to declare the characteristics equation of this given control system whose forward path gain is exactly equals to how much, which is given in this numerical k divided by this whole term, right? So first of all, we need to equate, or we need to decide the characteristics equation. Once we are having the characteristics equation, then after that, according to the basic theory of this Routh stability criteria, with the help of this characteristics equation, when it is being mapped with the help of different coefficients, so all these coefficients are being arranged within this Routh array, because this will be the basic strategy belongs to this Routh criteria. Each time we are supposed to declare one Routh array belongs to this characteristics equation, whose elements are nothing but what? The different coefficients which are lying at even and odd position within that characteristics equation. So let us quickly go through the characteristics equation for this system. So for sake of this moment, one more time, I will rub all this thing. So this is only for our understanding how to get the characteristics equation of this unity gain system with the help of this negative feedback. So as I told you earlier, in this form we need to write this characteristics equation ki 1 plus g of s into h of s equals to 0. H of s equals to 0. Here h of s is exactly equals to how much? As it is a unity gain feedback means h equals to 1. So we need to rewrite this numerator in this way, 1 plus g of s into h of s. So it will become this 1 plus this whole term which is written within this rectangular box, k divided by s into s square plus s plus 1 into s plus 4, right? So 1 plus g of s into h equals to 1 equals to 0. So this is how your characteristics equation will look like. Then after that, a very simple mathematical simplification we need to do. This whole term will get multiplied with this one. So as a result of this, it will become s into s square plus s plus 1 into s plus 4 plus k equals to 0. Then after that, this s will get multiplied within this parenthesis. So it will become s raised to 3 plus s raised to 2 plus s into s plus 4 plus k equals to 0, right? Then as we are having these two parentheses with us, so these two parentheses are being multiplied with each other, so term by term multiplication there will be. So initially this s will get multiplied with this whole parenthesis, and after that 4 will get multiplied with this whole parenthesis. So as a result of this, it will get s raised to 4 plus s raised to 3 plus s square. Then plus, now it's time to multiply this 4, so it will become 4 s raised to 3 plus 4s square plus 4s plus remaining term is what? K equals to 0. Then after that, when we rearrange this term in this descending order, so s raised to 4, how many terms we do have with us belongs to s raised to 3. So s raised to 3 plus 4s raised to 3, so it will become 5s raised to 3 plus 4 plus 1, 5 s square, now plus 4s plus k equals to 0. So now this whole term can be called as a characteristics equation, right? Once we are having this characteristics equation with us, then after that what we need to do, we need to assign the different coefficients for these characteristics equations, or for this characteristics equation. The coefficient, the count of that coefficient always begins with this a0, a1, a2, a3 and a4, right? So these 5 different coefficients we are having with us belongs to this characteristics equation, starts from a0 to a4. Then after that, what we need to do, once we are having these coefficients with us, then after that we need to declare one Routh array from this characteristics equation, right? So how to declare this Routh array? Here I will write. So within this Routh array, first of all, we need to observe, from sake of observation, we need to observe ki what is the highest degree of s, right, in this characteristics equation. So highest degree of s is s raised to 4. So this will be written in this descending order: s raised to 4, s raised to 3, s raised to 2, s raised to 1, and lowest degree of s is what here? S raised to 0, right? Then after that, what we need to do, already we had discussed how to declare the elements of this Routh array. Within that first row, we need to collect all the elements which are lying at even position, right? Even position starts with this 0th count, so a0, a2 and a4. So a0 is nothing but what? S raised to 4 times, so the coefficient for this s raised to 4 is 1. The next even term is a2, that can be map as a 5 times of s square. Here the coefficient of s square is how much here? 5. So here a2 will become 5 after this a0. a4 equals to what? This kth term itself is a a0. We are supposed to declare the desired range of this k for sake of stability, right? Then within that second row, we need to collect all the elements which are lying at odd position. Odd position means what? First element will be located at that position, that can be mapped as a a1. So a1, a3, a5, a7 like this. So this 5s cube can be treated as a a1. So the coefficient of this s cube is nothing but what? 5, s raised to 3. The next OR coefficient is located at A3, 4 into s raised to 1. So the coefficient of this s raised to 1 is 4. Now we don't have this A5 term, so it will become 0, right? Now how to decide the element which is present at that third row? So in order to decide the elements which are supposed to be declared within that third row are to be tabulated with the help of first two rows by doing simply the cross multiplication with each other, right? So here this element is to be tabulated. For that purpose these two elements are being multiplied with each other. 5 times of 5 into 5 minus 1 into 4, right? This 5 into 5 minus 1 into 4, its denominator will become what? 5, right? So in this way 5 5 is 25 minus 4 divided by 5. So it will become 21 divided by 5. So 5 4s are 20, 4.2. So the element which is present at that third row will be 4.2. Now in order to decide the element which is present at row number 3 and column number 2, what we need to do? For sake of moment, we need to hide this column number 2, and this cross multiplication is to be done, right? So 5 will multiplied with k minus 1 into 0, this term will become 0 divided by 5. So this 5 will get cancelled, remaining term is nothing but what here? K. So this element equals to k. Now no doubt about this element equals to 0, right? Then after that, in same manner, in order to declare the elements belongs to this s raised to 1 row, previous two rows are being taken into account, means s raised to 3 and s raised to 2, right? So in order to get the element which is present at this s raised to 1 row, this 4.2 will get multiplied with this 4. Okay friends, so element belongs to this row number 4, means the coefficients belongs to this s raised to 1 row. In order to decide this element, previous two rows are being taken into account. In same manner, this 4.2, here I will write, this 4.2 is being multiplied with this, wait a minute, this 4.2 is being multiplied with this 4 minus 5 into k, these two elements are being multiplied. Minus 5 into k divided by 4.2. So 4 4 is 16. So basically 16.8 minus 5k upon 4.2, right? So the element which is to be written here, so it will become 16.8 minus 5k. We will keep this element as it is in order to decide the overall range for that k. Here the element will become 0. Now finally the elements belongs to this s raised to 0 row. For that purpose, similarly, we are in need of previous two rows, means these four elements. So obviously it will become, this whole term will get multiplied with this k, right? Minus 4.2 into 0 means obviously it will become 0 divided by again this whole term. So how it will look like? This 16.8 minus 5k into k divided by 4.2, this whole term again 16.8 minus 5k divided by 4. So these two terms will get cancelled. The remaining term is nothing but what? Only k. So once we are having all these elements belongs to this Routh array, so this Routh stability criteria says that if all elements belongs to first column are positive, then and then only that system can be called as a stable system. Here our objective is to what? Find the range of k for stability, means by default this is the stable system. So for its stability we need to decide the desired range of this k, right? So that is our objective. So the range of k is to be decided with the help of this Routh array. As far as this Routh array is concerned, so within this Routh array, the first column of this Routh array, first element is nothing but what? 1, it is positive. Second element is 5, no doubt positive. Third element is 4.2, greater than 0. Then the next element is nothing but what? 16.8 minus 5k upon 4.2. So here I will write this 16.8 minus 5k upon 4.2. It should be greater than this 0. So it will become again this 4.2 will get multiplied with this 0. So 16.8 minus 5k, this should be greater than 0. Then after that again that can be rewritten as a 16.8. It should be greater than this 5k. So obviously k it should be less than 16.8 minus 5. So k equals to 5 3s are 15. So 3.6 approximately it is, right? 3.6. The desired value which is coming out of from this element number 1, 2, 3, 4. So again this 3.6 means what? Again it is greater than 0. This will be the maximum value of that k. We are in need of that desired range, minimum to maximum, and minimum value will be what? For that minimum value k should be greater than 0. So the desired range for this k will be what? 0 less than k less than this 3.6. So I will put this term within this rectangular box. So in this way the desired value of that k is to be decided for stability with the help of this Routh stability criteria. So we can say that this will be one of the most important application of this Routh stability criteria. We can decide the desired range of this unknown variable for the overall stability of that given control system, or for the stability of that closed loop control system. So I just hope that you had understand all these things belongs to this Routh stability criteria. Thank you.